Einstein's forbidden time travel blueprint. What if I told you that Albert Einstein, the man who rewrote the laws of our universe, also accidentally left us a blueprint to break them? Tucked away deep inside his theory of general relativity is a concept so dangerous, so profound, it threatens the very fabric of cause and effect. It's a mathematical loophole in reality itself. It's called a closed, time-like curve, and it is the closest thing theoretical physics has to a real-life time machine. This isn't science fiction. It's a consequence of the very same equations that predict black holes and the bending of starlight. But to follow this blueprint would be to unleash a storm of paradoxes, a logical hurricane that could unravel reality. This isn't just a story about traveling through time. This is the story of a hidden key to the past, and why the universe might do everything in its power to stop us from ever using it. The dream and the wall. For as long as we've understood the linear march of time, we've dreamed of breaking ranks, of stepping out of the relentless one-way procession from yesterday to today to tomorrow. And the fantasy is intoxicating, isn't it? A chance to witness history, to fix a tragic mistake, to see a loved one just one more time. It's a desire so fundamental, it has fueled 1,000 stories. But for the longest time, physics had a very clear answer. No. The universe, as we understood it, was a place of strict rules, and the most fundamental rule of all was the speed of light. Einstein's earlier theory, special relativity, established light speed as the absolute, unbreakable speed limit of the cosmos. Nothing with mass can reach it, let alone surpass it. This cosmic speed limit is hardwired to the flow of time. The faster you move through space, the slower you move through time relative to someone standing still. This isn't a guess. It's a proven, measurable fact. GPS satellites, whipping around the Earth at incredible speeds, have to constantly adjust their clocks. If they didn't, the GPS on your phone would be off by about 10 kilometers or 6 miles after just one day. This effect, time dilation, offers a one-way ticket to the future. If you built a spaceship that could travel at 99.99% the speed of light, you could journey to a distant star and back in what feels like a few years. But when you returned, you'd find that centuries, even millennia, had passed on Earth. You would have successfully time-traveled to the future. But what about the past? That always seemed impossible. Going backward would mean exceeding the speed of light, somehow throwing your temporal momentum in reverse. And according to special relativity, that was a cosmic non-starter. The universe had locked the door to yesterday and thrown away the key. For decades, the wall was absolute. The law was clear, until Einstein's next theory. A theory so powerful it would change not just our idea of gravity, but the very nature of space and time. And hidden within its labyrinthine map, a few brilliant minds would find something no one expected: a crack in the wall. Einstein's revolution, the fabric of reality. To understand how Einstein accidentally opened the door to time travel, you have to get to know his masterpiece, the general theory of relativity. Published in 1915, it completely reimagined the universe. For over 2 centuries, Isaac Newton's idea of gravity reigned supreme. Newton told us gravity was a mysterious force that massive objects exerted on one another across empty space. An apple falls because the Earth pulls it. It worked, but it didn't explain why. Einstein wasn't satisfied with the mysterious force. He proposed something far more bizarre. He said there is no empty space and no force of gravity in the way Newton thought. Instead, space and time are woven together into a single 4-dimensional fabric, space-time. The best analogy is a vast, flexible trampoline. With nothing on it, the fabric is flat. But place a massive object, like a bowling ball, in the middle, and the fabric warps and curves. Now, if you roll a marble nearby, it won't be pulled toward the bowling ball. It will simply follow the curve in the fabric that the bowling ball created. It thinks it's moving in a straight line, but the very ground beneath it is bent. That, Einstein said, is gravity. Gravity isn't a force, it's the geometry of space-time. The sun creates a deep well in the fabric of space-time, and the Earth is constantly rolling along the edge of that well. We aren't being held by an invisible rope. We're following a path carved into reality itself. This was monumental. It even predicted that light, which has no mass, should have its path bent by a massive object, because it too must follow the curves in space-time. In 1919, astronomers watched starlight bend around the sun during a solar eclipse, exactly as Einstein's equations predicted. Einstein had revealed a deeper, stranger truth, but this new reality had consequences that made even Einstein uneasy. If matter can bend space, can it also bend time? Yes. The deeper you are in a gravitational well, the closer you are to a massive object, the slower time passes. This is gravitational time dilation. Those GPS clocks don't just run slow because of their speed. They also run a little faster because they're farther from Earth's gravity. Both effects have to be calculated for the system to work. By revealing that space-time wasn't a rigid stage, but a dynamic, malleable fabric that could be bent, stretched, and twisted, Einstein had unknowingly opened a Pandora's box. If space-time can be warped so dramatically, could it be warped enough to loop back on itself? Could you twist the fabric so intensely that a path leading forward in time eventually returns you to where you began? Einstein himself probably didn't think so, but his equations, the very math he gave the world, told a different story. The forbidden blueprint, closed time-like curves. The first person to find one of these time loops hiding in Einstein's equations wasn't some household name. It was a physicist named Willem Jacob van Stockel in 1937. But the idea truly exploded onto the scene in 1949, thanks to one of Einstein's closest colleagues at Princeton, the brilliant and eccentric logician Kurt Gödel. He decided to give his friend a unique 75th birthday present. He solved Einstein's field equations in a new and deeply disturbing way. Gödel was probing the theory's philosophical limits. He asked a simple question: what if the entire universe was rotating? Einstein's equations don't forbid it. So Gödel cooked up a mathematical model for a universe filled with uniformly spinning dust. When he solved the equations for this hypothetical cosmos, he found something extraordinary. In Gödel's universe, the rotation of all matter drags the fabric of space-time along with it, a bit like a spinning mixer dragging cake batter. Gödel took this effect, known as frame dragging, to the absolute extreme. He showed that in such a universe, the constant twisting of space-time would cause the light cones, the possible future paths for any object, to tilt over. If you traveled far enough, your future path would actually loop around and intersect with your own past. He had mathematically proven the existence of closed time-like curves, or CTCs. A curve is just a path through space-time. Time-like means it's a path a real object can follow without breaking the speed of light. Closed means it's a loop. A CTC is a route you can take through space-time that brings you back to the same place and time you started. Gödel had found a blueprint. Now Gödel's rotating universe isn't our universe. Observations show ours is expanding, but the door was now open. The question was no longer if general relativity allowed time travel, but whether the right conditions could actually exist. Other physicists found different solutions with these forbidden loops. One famous idea is the wormhole, or Einstein-Rosen bridge. Popularized by physicist Kip Thorne, a wormhole is a theoretical shortcut through space-time. But to turn this shortcut into a time machine, you'd have to manipulate it. If you took one mouth of the wormhole, accelerated it to near light speed, and then brought it back, time dilation would make the two ends exist in different times. Step one way, you go to the future. Step the other, you're in the past. Another concept is the Tipler cylinder, which requires an infinitely long, incredibly dense cylinder spinning near the speed of light. Much like in Gödel's universe, this would drag space-time so intensely that if you flew a specific spiral path around it, you could arrive back in your own past. The infinitely long part, of course, is a rather significant hurdle. All of these ideas rely on one principle: warp space-time so severely that you create a closed, time-like curve. The math works, at least on paper. But what happens when you try to follow that blueprint? What happens when a traveler steps into a world that has already been written? The answer is a logical cataclysm: the paradoxes. The storm of paradoxes. A closed time-like curve is like a lit match in a fireworks factory. It's small, but it can set off a chain reaction of chaos that defies all logic. These are the time travel paradoxes, the universe's ultimate defense against anyone trying to rewrite history. The most famous is the grandfather paradox. You build a time machine, go back, and cause the death of your grandfather before he meets your grandmother. If he dies, one of your parents is never conceived. Therefore, you are never born. But if you're never born, you couldn't have built the time machine to kill him in the first place. It's a perfect contradiction, a sentence that negates itself. If he dies, you aren't born, so you can't kill him, which means he lives, which means you are born, which means you can go back and kill him forever. The timeline crumbles into logical dust. Then there's the other, stranger kind of paradox. One not about contradiction, but about origin. This is the bootstrap paradox. Imagine a physicist struggling to invent a time machine. One day, an old, mysterious scientist appears, hands her a complete set of blueprints, and vanishes. The physicist uses them to build the machine, becomes famous, and then, in her old age, she takes the blueprints, travels back in time, and gives them to her younger self. So, where did the blueprints come from? The older scientist only had them because her younger self received them. The younger scientist only got them because her older self brought them back. The information was never created. It has no origin. It just is. Who wrote Hamlet? Imagine a time traveler who loves Shakespeare goes back to meet the bard, only to discover he's an illiterate stable boy. In a panic to preserve history, the traveler publishes the plays he brought with him under Shakespeare's name. So who wrote Hamlet? Not the traveler, he just had a copy. Not Shakespeare. The plays were never authored. They were bootstrapped into existence. If Einstein's blueprint is real, then the universe must have some way of dealing with this logical storm. Does it just forbid time travel? Or is the solution even more mind-bending? The universe fights back. Faced with the threat of paradoxes, physicists have wondered, if the math allows for time travel, why isn't our history crawling with tourists from the future? The answer might be that the universe has its own set of rules to protect causality. The first proposal came from the great Stephen Hawking. It's called the chronology protection conjecture. Hawking found paradoxes so ugly that he guessed there must be some undiscovered law of physics that stops closed time-like curves from ever forming. He jokingly called this the chronology protection agency, a force of nature that makes the universe safe for historians. The idea is that the very act of trying to create a time machine would destroy it. For example, the energy from quantum fluctuations might build up at the entrance to a time-traveling wormhole, feeding back on itself until it grows infinitely powerful and destroys the gateway an instant before it can be used. But what if the universe is less of a cop and more of a clever editor? This brings us to the Novikov self-consistency principle. This principle doesn't forbid time travel. It forbids paradoxes. It says that if you travel to the past, the laws of physics will conspire to make sure your actions are already part of a self-consistent history. In other words, you cannot change the past. Period. If you go back to kill your grandfather, something will stop you. The gun will jam. You'll slip on a banana peel. You'll have a sudden change of heart. Any action you take was always the action you were going to take. Your journey isn't an intrusion on history. It's a part of it. The bootstrap paradox isn't a paradox here. It's just how things work. The timeline is a single, unalterable block of concrete. You can move along it, but you can't carve it into a new shape. There is a third, even more speculative possibility from the weird world of quantum mechanics, the many worlds interpretation. This idea suggests that every time there's a quantum choice, the universe splits into a new, parallel timeline. When you travel to the past, you don't enter your own past. You enter the past of a new, branching timeline. In this scenario, you can kill your grandfather, but you don't vanish. You've simply created a new universe where you will never be born. Your original universe, the one you left, remains untouched. This neatly avoids the paradox, but at the staggering cost of creating an infinite number of parallel universes. We've journeyed from Einstein's elegant equations to the edge of logic and time itself. If you love exploring the mind-bending frontiers of science, hit that subscribe button and join us as we try to unravel the next great cosmic mystery. So, did Einstein leave us a viable blueprint for time travel? The answer is a resounding and perhaps frustrating maybe. His theory of general relativity shows that under some exotic solutions, space-time can theoretically loop back on itself, creating a pathway to the past. The mathematics is there. The blueprint exists. But it's a blueprint for a machine that may be impossible to build, requiring things like exotic matter that may not exist, or infinitely long, spinning cylinders. And even if we could build it, we face the storm of paradoxes. Perhaps Hawking was right, and a cosmic law protects history. Or perhaps Novikov was right, and history protects itself. What we're left with is a beautiful tension in the heart of physics. A tantalizing possibility, forever guarded by logic and the immense scale of the cosmos. The door to the past may not be locked, but it appears to be protected by dragons. And for now, all we can do is stand on this side of it and wonder.